To understand the application of acids and bases applicable to hair, you must first understand the structure of a hair. The pH of hair lies between 4 and 5. A hair is made up of 3 layers. The cuticle on the outside, consisting of cells that overlap each other to protect the cortex. The cortex is the layer just below the cuticle and consists of hard keratin, a type of protein. The color pigments are situated in the cortex, as well as the bonds that determine the properties of straight or curly hair. In the middle is the medulla, that consists of soft keratin. It is only the cuticle and the cortex that play a role in hair treatments. Cystine, an amino acid, consists of long chain structures that are bonded sideways to each other by physical bonds, namely hydrogen bonds and salt bonds. These physical bonds are broken easily by heat and water when it causes a small change in pH. These changes are temporary. As soon as you wash your hair, the bonds recover and your hair returns to its natural state, and you must blow dry it again or use hot tongs to change the hair the way you want it. Chemical bonds form between 2 sulfur atoms. These disulfide bonds that also occur in cystine do not break easily and are permanent. Only a big change in the pH can alter the structure of a hair to bring about a permanent change, because it makes the hair swell up, causing the cells of the cuticle to lift up so that the chemicals can reach the cortex. The number of disulfide bonds determines the strength of a hair. Curly hair has many disulfide bonds, and the hair shaft is more oval or even flat. Straight hair has less disulfide bonds, and the hair shaft is more round. A big change in pH will disturb the external hair structure permanently, like when you use hair relaxers like a Brazilian that will make your hair straight, or if you perm your hair, which is a permanent wave. Both these processes are permanent and grow with the hair. During a permanent wave, a wave solution such as ammonium thioglycolate is used so that more disulfide bonds can form. This solution changes the pH so that it is between 8 and 9,5, and reduction takes place to break the disulfide bonds between the chains. Cystine changes to cysteine when hydrogen bonds to the sulfur atom where the sulfur-sulfur bonds were broken. The structure is then changed from a straight hair to a curled hair that will be determined by the roller. To stop the process, hydrogen peroxide is added, which will lower the pH, and the reaction is neutralized. The cysteine changes back to cysteine, where new disulfide bonds form that will remain. The forming of disulfide bonds is an oxidation process. During permanent relaxation, a strong base such as sodium hydroxide or potassium hydroxide with a pH between 12 and 14 is used to make the hair swell up so that the chemicals can get to the cortex. During a reduction process, the cysteine changes to cysteine as the disulfide bonds are broken and hydrogen bonds to the sulfur. The hair is then stroked with hot tongs to relax the curls, because there are now fewer disulfide bonds. To stop the process, Diluted ethanoic acid, which is vinegar, is added. The pH is lowered, and the reaction is neutralized. The cysteine changes back to cysteine, with fewer disulfide bonds that form during oxidation, and it remains in the straight hair. When hair is colored permanently, the cuticle must first swell up and open, so that the colorant can get to the pigment cells in the cortex. This can only happen with a change in pH. Hydrogen peroxide and ammonia are used in hair colorants. H2O2 and NH3 are alkaline and will raise the pH to between 7 and 8. At this pH, the hair swells and the cuticle opens. The new color is absorbed and reacts with the pigment cells. After the hair is rinsed well, the cuticle returns back to normal, and the colorant is now permanently captured in the cortex and will grow out with the hair. Color shampoos are not permanent. The colorant only bonds to the surface of the cuticle and will then wash out again. Let us summarize.